Welcome back to our video series on creating a data analyzer for the COVID-19 dataset. So we're going to start off this video by doing a quick either math review or might be the first time you're seeing it, but a quick discussion on exponential growth. So this is a website that I found by just Googling exponential growth. You'll notice it's an Algebra 2 website, so that's about the level of math we're using here, nothing super advanced, but if you're not in Algebra 2, it's okay. In fact, this idea of exponential growth is actually introduced in Algebra 1. These are the models or the equations. So when I say the word model, don't think like a model airplane, think model as in like an equation. So given some input, we get some output. So this is the kind of exponential growth you explore in Algebra 1. And this is usually applied like if you're going to have certain rate of growth per year or per day or things like that. But a lot of growth models are actually what's called continuous growth. So like bacteria, or sometimes we think of virus growth in this model. And so this is what continuous growth looks like. So the amount that we have after a given time, usually time is days or years, again, it just depends on what you're writing your model for, is equal to the initial amount times this number e, where e is actually 2.71828,183, and it's kind of like pi, it keeps going forever. So it's the initial amount times e to the power of kt, where k is our growth rate, and then t is, again, the amount of time, dependent on what we're modeling against. So I think in our case, t is going to be days. So with that in mind, this is going to be the equation that we're going to be using. You may also have seen this as like y equals pe to the rt. So it's the principal times e to the rt. So it's the same formula. So we're going to be using this formula in conjunction with this library in Python called SciPy. And what SciPy does, it allows us to basically take some data and then call this, we're going to use this optimize function that's going to basically come up with a best fit model for a given function. So as we can see, you can have, these are some plot points, right? And then you can get this graph of if it were this type of a graph, this is what the line would look like. You'll notice here how we write here, it says from SciPy.optimize import curve fit. So we're actually going to be using that. And then the key here is we're going to have to actually write a function with coefficients as parameters. So notice this, they call it test xab, right? So we're going to be using something very similar to this for ours. And then what we're going to do is we're going to call a curve fit, and we're going to pass in it's the function, and then this curve fit function takes the test function, x data and y data as argument, and returns the coefficients a and b in the parameter, and then the estimated covariance, or like how close it is to fit. Okay, so we're going to be using this idea here to write some code. So the first thing we have to do is we're going to do from SciPy optimize curve fit. So let me go ahead and switch back to my my code here. So here we go. All right, so from SciPy dot what was it again? Optimize. Now at this point, if you don't have SciPy working, then you're going to have to ask for help. So make sure you don't go on until you get SciPy working. So from SciPy optimize import curve underscore fit. Is that right? Doesn't seem right. No, that's right. I'm going to go ahead and just run this and see if it works. Python COVID.py. Cool, I didn't get any errors. So we're going to generate an exponential growth model. So the first thing I'm going to do is I'm going to define a function. I'm going to call this exp func. And as we saw before, it needs to have x, a, and b as our parameters. Now, so yeah. And so then what we're going to do is we're just going to, well, we're going to have to use, we need an x. So our equation, remember, is, I'm just going to put a comment here. All right, so we want something like a, or it's actually y equals a times e to the power of k times t. Right, that's the idea. Okay. So we want to write our function is just going to return essentially this. Okay. Now to do e to the power, that's going to be an exponential function. So I'm just going to say from math import exp, returns e raised to the power of x. So that's what I want. Cool. And so we're going to return a times exp, and then we want kt times t. So it'd be b times x. Okay. All right. I think that's how we want it. Now they're doing the numpy.exp. It's the same as what we're doing essentially. Okay, so then we're going to have param covariance equals curve fit test xy. Okay. So let me hide that and go back to our code here. All right, so we're going to do this inside of our class. And remember, inside of our plot where we got our y and our x, we're going to kind of do the same thing. Okay. So I'm going to define a function and call it get model. And for now, we're going to get a model for right now over all of the data. And then what we'll do is in another video, we'll figure out how to just get model over subsets of the data. Kind of like what we did in plot, but a little bit different. Okay, so we're going to get the model. So I kind of want to do the same thing as I did before, where I get my y and my x. Right, so I'm going to go ahead and I'm just going to copy this and paste it here, except now I'm not going to do a subset. I'm just going to let y be all of the values. Okay. So then I'm going to go back just to show you what I'm talking about here. I'm going to go back to this page and notice how we have the curve fit actually returns think of like a tuple. It returns something that's the parameters, which is actually going to be, I believe it's a list, and then a parameter covariance. But for right now, I'm just going to type this in just like I see it here, except instead of test, it's whatever the name of our function is. Okay. So again, let me go back to our code. All right, so I'm just going to say param covariance equals curve fit, and we're going to give it our function, which our function was called expfunc. Okay, and then our x and our y. And then just for the purpose of right now, I'm going to go ahead and print an f string. Let's say param, just so we can see what it's actually resulting in. And then on a separate line, I'm going to print covariance, which is param underscore cov. All right, so when I run this, when I call get model, which I know plot works, I'm going to go ahead and comment that out for right now. I'm just going to say c.getModel, save, and we'll run this and see what errors we get. Only size one arrays can be converted to Python scalars. So I was afraid this would happen. I'm not afraid, but I thought it might happen. What we actually have to do is we need to give, so right now we're trying to give this function a list, and it doesn't want that. It actually wants an array. So what we're going to do is we're going to have to import numpy. So, okay, so let's go ahead and do import numpy as np, just so we can just don't have to type in numpy every time. And then we'll have, the way we turn a list into an array is we'll just say np.array of this list. And that's going to convert that list into an array. Now an array is in most ways like a list. It's just the way it's stored in memory is a little bit different. And so there we go. Now one other issue. So if we try to run this right now, I think we get an error. Yep. I think the way we fix that is instead of just using, so right here I say from math import exp, I don't think that's actually going to work. I think we have to use numpy's version of the exponential function. Let's see if that fixes it. It does. Cool. So for whatever reason, numpy's exp, which is the exponential function in numpy, takes in a different argument type than math exp. So yeah, so we'll just remove that math.exp. Okay, so if we look at what printed here, we can see the parameters. All right, got parameters and the covariance. For our purposes, the covariance really isn't going to be all that useful. We're pretty much going to ignore it. But the parameters we should be able to use. Okay. And so I'm just going to go ahead and run this one more time here. Now, these parameters, again, think of it like this. This is telling us A, and this is telling us B. So essentially what this is saying, if we go back to our equation here, is this is saying we have negative 3.92 times 10 to the negative 14th. So basically 0, right, times e to the 1t. Like that's basically what we have here. Now, this means that it's really not a very good model. I'll try to explain, but the way we have it right now is not going to be a very good model. So yeah, it's mostly because if we look at our data, as we saw before, it wasn't exponential for a while, right? It wasn't until we started looking at it a little bit further down when we saw the growth. And that's because we see, just looking at it, we have 1 with the exact same number multiple times, and then the same number. So for a while, it's not really exponential. In fact, until we start seeing a change in numbers, which is, around like February, I don't know, maybe, see, we have 13, 13, 13, 15, 15, and then 51, 51, 57, 58, 60. Until we start seeing this change on a daily basis, it's really, an exponential model is not going to fit it very well, which means we probably don't want to include that data in our model. So we probably want to start closer to, right here where it starts changing every single day. That's when we're going to expect to actually see that that exponential growth over time, or this model be a better fit. So we'll figure out how to do that in a little bit. Let's go ahead and let's have this get model. We're gonna go ahead and make a in our init method. I'm gonna go ahead and make a self.model params. We'll just make that empty. I'm gonna set it to 0, 0. Okay. So then when we get the model, what we're gonna do is we're gonna say self.model params equals param. Okay. So when we call get model, which we would want to do after we load data. All right, so we'll load the data. We're going to get the model. All right. And then once we have the model, we want to do something with it. All right, so let's go ahead and say predict. All right. And for the prediction, let's go ahead and just say we're going to predict for the number of days. So that'll be the number of days, I guess, in the future. All right, so we'll work on this. So the number of days in the future. So we have our model, right? We know, yeah. So we have our model, and we'll have this predict, 10 days, 20 days, 100 days, whatever, right? So remember, we already have, 60 days of data here, which means we can use our prediction and predict out, say, 60 days, and we can compare it with reality here, okay? So remember, our A is self.model params at index 0, and B is self.model params at index 1, right? We can also just say AB equals self.model params, and it'll automatically unpack A and B. All right. And so then what I'm going to do is say for I in range num days. And I'm going to make a list of these results. So I'm just going to say results equals list, or not results, predictions. Predictions equals list. Right. And so then we can say, now remember our function, the x func, it's expecting x, a, and b. Well, I is really, so what I'm going to do is I'm going to say, you know what, for x in range num days, let's go ahead and say prediction equals exponential func x, a, b. And then let's go ahead and just append our prediction to our predictions list. Okay. And then we'll go ahead and just, let's go ahead and just, I guess we can print predictions for now. We'll probably return this in a second, but all right. So we're gonna have c dot predict, and let's have it predict, I don't know, 60. Let's just see what happens. We might get an error, I don't know. Okay, cool. We didn't get an error, but we also notice we're getting a bunch of negative numbers, which, I don't know, something definitely seems off here. All right, something definitely seems off. So I think that our problem here is that our model, as we saw, we were getting negative right here. This was a negative value. All right. And I don't know why.
A few moments later. Many minutes later.
I'm going to try changing this. I wonder if instead of starting at 0, if it started at 1, if that would make a difference. So I'm going to make this go from 1 to that. Let's just see. So we didn't get negatives now, at least. Okay. So again, though, notice how we're getting these weird numbers, starting with very close to 0 for a long time. And again, that's because our data isn't really exponential for a while, right? So I think what we're going to do is we're going to make this, I'm going to switch this back to what it was. But for y, instead of being the entire data set, I'm just going to start it at, say, day 30. All right, so start at day 30. Let's see if that makes a difference. Okay. So we start at day 30. We see that it's predicting let's see here. So day 30, it's predicting 1 on day 30, 2 on day 31, 3, 2.8 on day 32, right, and so on. Now the question is, so we see 25,000 right here. The question is, does that correspond with this date right here? think that's going to have to be it for this video, though, because I don't want to get, too long. So I'm going to break this up into multiple videos here. So we do have it generating a model. We're going to have to look and see what exactly it's giving us for parameters to see if that's reasonable. And then we need some way of turning this list of numbers into dates to see if it corresponds in any shape, form, or fashion with these dates. So yeah, so that'll be probably the next couple of videos, is figuring out what this data is telling us. Again, we have a model. We have an exponential model. Not exactly sure how good of a model it is just yet, but that we'll look at in a little bit. So thanks for watching this video, and in the next one, like I say, we'll continue on to the same plan.